Okay, today I've set up what I'm calling a virtual lab, whereby I'm just going to give you some data that, in a regular class you would have recorded yourself. But we'll see all the steps and it'll be interesting. All right. So in the lab, you would hang different masses from a spring, measure the length of the spring after each of those masses are on, and then use a line of best fit to determine spring constant. I'm actually going to show you two ways of doing that. One with just graph paper, and then I'll show you a way with your calculator that involves pushing a lot of buttons, but will be very useful if you plan on taking Physics 30. All right, so let's do this. So these are the masses in grams, and then this is the length of the spring when the mass is hung from it. Now, if you remember Hooke's law, it's F equals kx. We're looking for k, and we don't actually have F or x. We can get it from here, okay? But what I'm going to suggest we do is expand our table. We can get the force from the mass, okay? These are in grams, though. We got to put those into kilograms and then multiply by 9.81. So I'll just show you the steps for the first one, just so we're all on the same page. 20 grams divided by 1,000. That's my kilograms times 9.81. These are my newtons. I'll call it 0.196. Okay, I'm just going to do the same and fill out the rest of this chart. Okay. So there's the force. That'll be the y-axis of our graph. And the displacement has to be the x-axis. And just notice this is the length of the whole spring that's stretched. In the equation, we only need the displacement. So the spring is 6 centimeters long on its own. And then this represents the total length after it's been stretched. So to get the displacement, I think I'll actually just leave this in centimeters. All we have to do is subtract 6 from each of these lengths, right? So if the spring is 7.1 centimeters long with this guy hanging off it, it means it's stretched 1.1 centimeters. So this should be pretty easy. All right, now we've got our data table complete, force, displacement. Okay, and like I said, I'm going to show you two ways of doing the graph.